Hello, this is at Teachers, Mr. Jones, and I'm coming with you with chapter 5.4, which is solving exponential and logarithmic equations. So I first want to go through the steps in solving exponentials. So we have two different types of exponentials, and we're going to have what's called, we'll separate them into two categories. We have simple, and then we have some more complicated ones. So we'll just say complicated. And the process can be the same for both, but it's a little bit easier if we separate it into two different ways of doing it. So with a simple, that is exponents on both sides. We will have exponents on both sides. So that's something like, let's say I have 2 to the x minus 1 equals 32. Okay, and for something more complicated would be with an additional term in there. So let's say I make it 3e to the 2x plus 5 equals 32, something like that. Okay, so with a simple exponential, we want to make, so step one would be make both sides have the same base. Okay, and if the bases are the same, okay, we can set the exponents or equal to each other. So then set exponents So we'll set the exponents equal to each other, and then we will solve it. So like that example I just gave you, we would write it, we'd say 2 to the x minus 1 equals 2 to the 5th. And then I'd say, since these bases are the same, then the exponents also have to be the same. So we'll say x minus 1 equals 5 and x equals 6. For the more complicated, okay, step one will be isolate the term with the exponential. So isolates term with exponent. And that's the exponent with the variable. So I need to isolate that term. Step two will be take the log of both sides with that base. So like here's base e. So I want to take the log of both sides with base e. So we'll say take log of both sides with correct base. And remember, if the base of the exponent and the base of the logarithm match up, we get to cancel it, and that's what we're trying to do. And the exponent comes down in front. Okay, so after that happens, then we'll just solve. Okay, so like we just have, we've got this example here. We'll first have to subtract the 5 over. So I'll have 3e to the 2x equals 27 divided by 3 divided by 3. E to the 2x equals 9. Okay, now to get rid of this e, we're going to take the ln of both sides. And so these cancel, and I'm left with 2x equals ln 9 and divide by 2. So x equals ln 9 over 2. Kind of ran out of paper there. So we can solve it that way. So either the simplified version, you're trying to make the base the same on both sides. And with the complicated, you're just trying to isolate that single term out. Okay, so now we want to look at steps in solving logarithms. Again, we have both the simple and we have the complex or complicated. And they're going to kind of be the same as what they were with exponential. So with the simple, we're going to have logarithms on both sides. So we'll say logs on both sides. Okay, so step 1 will be to combine logarithms on each side of the equation. Okay, so we're going to get it. So get single log of the same base on both sides. Okay, so I have like a log 10 and a log 10 on both sides of my equation. Step 2 is going to be set the inside equal to each other. Step 3 will be solve, and step 4 will be check. You always need to check your solutions, okay? For the complex, okay, one of my sides isn't going to have a logarithm. So step 1 will be combine / isolate the term with the logarithm, so the log. Step 2 will be to rewrite as exponential. I'll abbreviate that. So rewrite as exponential. Step 3 will be solve. And step 4 will be to check your solution. Okay, so for example on this one, a simple one that I might have might look like this. Okay, and a more complicated one here might look something like this. So log base 5 x plus 2 minus log 5 of x equals 2. Okay, so for the simple one, we've got a log base 10 here. I'm going to combine those two. So we'll say log of x minus 3, addition, we do multiplication equals log of 4. Okay, so since my logs here are the same, the insides have to be equal. So we'll say x squared, I'll go ahead and distribute that, minus 3x equals 4. This is a quadratic. We set it equal to 0, we factor it, and then we check our solutions. So minus 4, x squared minus 3x minus 4 equals 0. I need factors of 4 that subtract a 3. That's 4 and 1. X. Signs are different. The bigger one is negative, so minus plus. So x is minus 4. Sorry. X is minus 1 or 4. So that's step 3. Step 4 is to check. So I need to plug this back in and check. Remember, these values inside here cannot be less than 0. They have to be bigger than 0. So if I put 4 in there, I get 1, I get 4, I get 4, I'm good. I get -4, I get -1. So this one is not working out. So my only answer there would be 4. Now, the more complicated version of this is I have a log here on one side. Okay, we're still going to combine them. So we'll say log base 5 of x plus 2 over x equals 2. Now we're going to change it so that it is in exponential. So we take 5 squared, so 5 to the 2 equals that, equals x plus 2 over 5. Oh, sorry, over x. So that's 25. Okay, so then if I multiply both sides by x, those cancel and I get 25x equals x plus 2. So subtract x minus x, 24x equals 2. So divide by 24, x equals 1 over 12. Okay. Now, again, I need to check that. So I will plug it in back here and check those solutions. Probably going to need to change a base formula for that on the calculator to do that. So that's the steps in solving for exponential and logarithmic. See here. So the next thing I want to discuss is why. Like, why do I need to know this stuff? Why do I need to be able to solve some of these exponential and whatnot? So the first reason is money. We talked about how like putting away some money so that it builds up in a savings account and figuring all that out with this formula. Okay, now what happens if you know how much money you want to put in and you know how much money you want out, you know the interest rate, you know it compounds quarterly, but I don't know time. How long is it going to take for $500 to build up to $2,000? Okay, you're going to need to know this. This will be exponential. You'll have to get that out. Another one we talked about was carbon dating. So that's like half-life or doubling time with this formula. Okay, what happens again if I don't give you the time or I don't give you the doubling rate? Maybe you're going to have to figure that kind of thing out. So there's a ton of real-life examples here that we can use, especially finance, health, medicine, chemistry, biology, sound. We can go back to the magnitude of earthquakes and the decibel level of some concerts and those kind of things. So this will be the stopping point for the video. Here are your questions. So 5.4, how do I get a variable out of the exponent? What are the steps to solving an exponential equation? And what are the steps of solving a logarithmic equation? Your suggested problems right here. So go ahead and get those going. If you would like to continue watching the video, I'll go over some more examples of what I'll be doing in class. So yeah. All right, thanks for tuning back in. So we're going to do some examples of chapter 5.4, which was solving exponential and logarithmic equations. So let's first just start off with something pretty simple. So that's an exponential there that we'll want to solve. So we want to try to get both sides to the same base. So this is already 3 to the x. So I'm going to try to get 81 as 3 to some power. Well, 81 is 3 to the 4th. Now, because the bases are the same, the exponents also have to be the same. So 4 would actually be my answer. Okay, so now let's look at something a little bit more difficult. Maybe something like that. So again, we want to try to put it into the same base. So I know that 2 to the 4th is 16. Okay, but I can't do it as a half. So if I take this exponent and make it a negative, that switches the sides here. So I'll take 2 to the minus 4y. And remember, a negative flips it upside down. So now I have my 2. And because the bases are the same, the exponents also have to be the same. So in this case, y is minus 1. So these are the simple versions of how to do that. Now, what happens if I can't or I'm unable to make both sides the same? So let's say I have something, let's switch colors here for the more complicated ones. Let's say I have something like 5 to the 3x equals 16. Now, I can't make 16 a base 5, okay? So in order to do that, since my term's already isolated, I'm going to take the log of base 5 to both sides. Okay. Now on the left side here, you notice that these cancel, and I'm able to bring this variable down. So I've got 3x equals log base 5 of 16, and then I divide by 3. So you get x equals log base 5 of 16 over 3. Okay. Now you probably, to put this into the calculator, are going to have to use a change of base formula. So when I put it in here, we'll say log of 16 over log of 5, enter, divided by 3. And we'll get about 0.574 for that one. Okay. Now, that one's still kind of simple compared to some other ones. Let's look at this one. Let's say 4e to the x squared equals 16. Okay, so we're going to divide by 4 because I got to isolate that base value. So I have e to the x squared equals 4. We're going to take the ln of both sides. So those cancel. I get x squared equals ln of 4. Okay. Then we're going to take the square root. And remember, anytime I take the square root, I have to do the plus and minus ln of 4. Okay. Which is about, if we do ln of 4, we get plus minus 1.39 for my answer. And it would be good practice to go ahead and plug that back in and get a solution. Okay, so let's look at logarithms real quick. So solving logarithmic equations. So here we've got log base 4 2x minus 3 equals log base 4x plus log base 4 of x minus 2. Okay, so notice I've got logs on both sides. So I'm going to make everything on each side to one logarithm. So here, to combine addition, we have multiplication, and I'm going to go ahead and distribute as I go. So I have x squared minus 2x. Okay, since the log and the bases are the same, they can cancel each other out. So I have 2x minus 3 equals x squared minus 2x. Again, it's quadratic, so I got to move everything to one side and factor or quadratic formula or one of those. So minus 2x plus 3. So 0 equals x squared minus 4x plus 3. So factors of 3 that add to 4. That's 1 and 3. X, signs are the same. They're both minus. So x is 3 and 1. Okay, so I have to plug these in and check them. So remember, this value in here has to be bigger than 0. So if I plug in 3, that's 6 minus 3 is positive. That 3 is positive. 3 minus 2 is 1, which is positive. Here, I've got 2 minus 3 is minus 1. So I cannot choose this because it becomes negative. So my only solution there would be 3. All right, so let's try another one here, a little more complicated. So let's look at log base 3 of 9x minus log base 3 x minus 8 equals 4. Okay, so I only have a logarithm on one side this time. So we'll combine, and we combine over division. So log of 3 9x over x minus 8 equals 4. We can rewrite this as exponential, okay, or I just take it to the base of 3. So I have 9x over x minus 8 equals 3 to the 4th, which is 81. And then I need to solve this. So we'll multiply both sides by x minus 8. X minus 8, those cancel. Distribute. So you have 9x equals 81x minus 648. Okay, and then we solve it for x, so minus 81. So negative 72x equals negative 648, and x is 9. Again, you have to plug this back in. 9 times 9 is 81. That's good. 9 minus 8 is 1. So that is also good. Okay. There'll be some more difficult ones, but just make sure that you're checking your solutions to know that you're getting the right answers. Okay, so there's some word problems with these. So you save $1,000 for a summer job, and you put into a CD earning 5% compounded continuously. How many years will it take for your money to double round to the nearest year? So you have $1,000, and you're putting it into this account over here, and you want it to double. Okay, so it'll be $2,000. The interest is 5% continuously. Okay, so we should remember that we need the A equals P e to the RT formula. Well, the amount I want in the end is 2,000. The amount I'm putting in is just 1,000. E, the interest rate is 0.05, and I want to know T. Okay? So then we're going to solve it. So we'll divide by 1,000. We get 2 equals e to the 0.05 t. We have to take the ln of both sides. That way those cancel. So I have ln 2 equals 0.05 t and divide by 0.05. So t equals, so we have ln of 2 divided by 0.05. 13.86 years. So it really needs to be into this account for 14 years before it will double. And this is the kind of stuff I'm talking about money and those kind of things. All right, so that's going to sum it up for chapter 5.4. Again, here are your suggested problems. Go ahead and try those out. Let me know how they go. If you got questions, I'm here early in the morning. As always, this is at THS Mr. Jones. Thanks for watching.